Welcome and good afternoon, everybody. I'm going to tell you something about the intersection between security, OGC API standards, and what we have been using for streamlining OGC API, our preferred tool, pygeoapi. Just a little bit of my background. I've been working extensively in the past with big organizations, with not only geo-related things, but even more with identity and access management. And this talk reflects basically what is my background. And thanks to Antonio, who was expected to run the talk together with me, but he couldn't join us. So let's introduce very quickly OGC API. There is this modern evolution of the OGC standards. We are more focused on being WebP, assist developers in building and doing something more REST friendly. And so the goal of this modern OGC API standard was basically the adoption of new patterns like the OpenAPI specification, and give to the developers, first of all, tools that can be easier to manage, to maintain, and to program. I'm going to tell you about the pygeoapi in a while. In that, this is basically a big picture about the landscape of the different API that are. Some of them are in draft. We have the stable version of OGC API Features, and the tool that I'm going to introduce you, pygeoapi. There will be a dedicated talk about the status of GeoAPI next days. So today I'm going very quickly to the tool because our primary focus here is to give you some solution about the security and how to protect OGC API. So this is basically the landscape of the API that OGC is promoting as the evolution. A really quick introduction about the standard in the industry about security. So just as a developer, you probably sooner or later you would end up to wonder how I can protect a specific endpoint, or for the OGC API a specific collection, or the item that belongs to a specific collection. This is where you have to focus. But first of all, as a good practice, it's not only to focus on the protection of your API endpoint, but to establish a very, I would say, a very communicative collaboration with your cyber security team, because obviously security it's not just the security of a particular endpoint, but it's more the process. So the best that we can do is a way to shift left, and so to implement the security in the design stage of your REST API. and I reported some tool that we are using. There is this tool Prizren that can help you to govern your security principle since the beginning by controlling what your OpenAPI document will look like and what kind of mechanism will provide for your consumers. Another important aspect, giving more on the topic of protecting an API endpoint, is the distinction between the two different moments of an access control. We have two different aspects. One is the authentication, and another one is the authorization. I'll give you an example. If you are going to a concert, you will buy a ticket. The ticket is your token to enter the stadium. But then it could be that in the stadium there could be some different areas that can be entered just if you have something, if you have more than just a simple ticket. For example, a bracelet. So if you have different color of this bracelet, maybe you can enter different private areas, and that's authorization, right? And this is what we want to achieve from a technical standpoint in our OGC API. What are the security aspects of an OGC API? Well, actually, the OpenGeospatial Consortium doesn't impose nothing about the security aspect, but what we are going to provide is just to rely on what OpenAPI, which is the standard, the specification where the OGC API rely, and provide a different security scheme in the OGC, in the OpenAPI document. So OpenAPI document is basically your contract in OGC API. You would provide this contract, and this contract can have some sort of security mechanism. I reported the most important one: HTTP, API key, OAuth 2, and OpenID Connect. I will show you about a couple of them in, not pygeoapi, but a downstream project of pygeoapi. pygeoapi is a reference implementation of the OGC API standard with this modern evolution. It provides different endpoints, it supports different capability of the API ecosystem, and it is a reference implementation of the OGC API Features, which is basically the replacement of WFS. And last but not least is an OnZero project. This is basically the architecture of pygeoapi. I don't want to go in detail here, but essentially I want to give you the message that pygeoapi is very modular and support different kind of web framework. We support Flask as the default framework for API in Python, but we also offer the possibility to build the capabilities, the OGC API function around Starlet and Django. And since we are supporting Starlet, we are able to support fast API application that I've seen in different toolkits, one of the most used framework right now. Now, what are the security that we established in pygeoapi? Well, we didn't establish security in pygeoapi. We didn't support out of the box the security because we want to be agnostic. Now, obviously, security can be, achieved at different level. You can basically you run your pygeoapi server. You basically publish the pygeoapi server on a private network, and that's it. You don't have to care about because probably you want to streamline your OGC API collection only to your only within your organization, and that's fine. But what if you are going to be internet facing? That's why you have to wonder how to protect an API endpoint. If, for example, the collection that you want to streamline contains sensitive information and you don't want to make this collection available to everybody. And that's what I'm going to provide you. The response to this demand is fastgeoapi API. Fastgeoapi is basically a downstream project that where we use pygeoapi as a library, and we build on top of the vanilla pygeoapi a security mechanism that cover the authentication part and the authorization part. We support two different mechanisms: the API key and the OpenID Connect. In the repository, we offer a sort of playground, right? So we basically developed a template which is using a very common, I would say, identity and access management tool, which is Keycloak, that supports OpenID Connect, among others type of access control, but nothing prevents you to use fastgeoapi with any OpenID compliance provider. So you can bind, I don't know, Google, GitHub, whatever, it is supporting OpenID Connect. And together with Keycloak, we, in fastgeoapi, we added a very specific tool, Open Policy Agent, that allows to program policies as code. I'm going to show you. It is a Golang binary server. In the repo, we basically offer you a Docker Compose, where you can type Docker Compose app, and you have the whole infrastructure up and running. And we provide even a simple authorization file with some sort of, again, a playground to, test, check it out, and test the different capabilities, how to protect collection from pygeoapi. This is very quickly the architecture. We have these two components, this Open Policy Agent and the Keycloak. Keycloak can be replaced by any compliant OpenID provider. Everything happens in terms of authentication and authorization at HTTP level. And I will show you how it looks like. And the fastgeoapi is simply a wrapper of pygeoapi. And in fastgeoapi, we use the very same variables that the vanilla pygeoapi uses. I'll show you in a moment. And in the playground, we offer even a template. We basically pre-generated a couple of users that can be used to see how the protection works. And then there is this Rigo file, which is the language how Open Policy Agent basically offer to the developers how to code the policy to make some endpoint accessible or not. And it is based on the HTTP request. I will show you in a moment. This is the 5 minutes, okay. I'll try to go faster. So we have this Keycloak configuration. You can basically check it out. Everything is already pre-generated. You can check the OpenID Connect token whenever you start the server and you perform some requests to the server. The authentication, here you see we have basically when the user is logged in, you receive these attributes. These attributes, it's a company and it's the user attribute that we are going to offer in the playground to basically test how a specific user from a specific company can access a specific collection in pygeoapi, while it will be denied for the rest of the other collection, and vice versa. This is how basically the simplest Rigo file, the policy, it looks like. This way, it's basically pygeoapi without any sort of limitation. The mechanism is up and running and control the access policies, but at this time, nothing is denied. And this is basically configuration, environment variables for the configuration of pygeoapi and the fastgeoapi application that wraps the library. This is how you can start the tool. And this is basically what I want to show you. If you uncomment the Rigo file, you will have everything already there for testing purposes. If you uncomment this Rigo file, basically you would end up with a specific user that will, for example, here you see the collection ops. It is allowed only for the user that belongs to the OGC company. While here, for example, the user that you saw before, Francesco Bartoli, it is allowed only for the collection lakes. These two collections are basically on the code base of pygeoapi. Yeah. Next to come, we are going to support pygeoapi transaction, which means that here in this Rigo language we have to just code not only request as here with the request method get, but even for the rest of the HTTP different methods, and that's it. Supports Rigo file. The Rigo file, it's just a file that you can push whatever you want. And we want to support Rigo file from remote Git repository. So to enable the pattern of policies as code. And probably build a UI application because the administrator likes UI on top of that. And that's it.